Creative Maths, including Statistics Learning Centre, brings you Bayes Theorem 1, Introduction. Hi, I'm Dr. Nick, and in this video I am going to introduce Bayes Theorem and conditional probability. Bayes Theorem is an extremely important formula which underpins a powerful concept. Strictly speaking, we should say Bayes' theorem, as it is the theorem belonging to Thomas Bayes. However, both Bayes and Bayes are used. I will use Bayes as it's easier to say. Here is Bayes' theorem, which is stated as a formula. The probability of A given B equals the probability of B given A times the probability of A all over the probability of B. We will illustrate this with some objects made out of coloured bricks. Here are some objects. If we put them in a bag and draw one out without looking, what is the probability that it has a yellow brick? We can see that there are 9 objects with yellow out of a total of 16 objects. The probability of drawing one out that is yellow is 9 out of 16. Now say I can tell you that the object I drew out has a red brick. What is the probability that it has yellow? There are only 5 objects with red, so we only need to consider them. 2 of the 5 with red have yellow and 3 have white. So we say that the probability of yellow given red is 2 out of 5 or 2/5. What is the probability of red given yellow? This means we know it is yellow, so we are only interested in the 9 objects with yellow. 2 are red and yellow, so our probability is 2 over 9 or 2/9. The other thing we need to consider is, what is the probability of red and yellow? We are back to having no information about the object. There are 16 objects, so each object has 1/16th probability of being picked. 2 of the objects are red and yellow, so the probability of red and yellow is 2 out of 16. This symbol is the intersection symbol and means AND. There are several ways we can represent this, using a table, a tree, and a formula. Here is a table summarizing the makeup of the objects. We calculate the probability of yellow equals 9/16. The probability of yellow given red equals 2 over 5 or 2/5. The probability of red given yellow is 2/9, and the probability of red and yellow equals 2/16. Tables make calculating probabilities much simpler. This tree shows the same data. Probability trees are sometimes used for modelling probabilities, but they are less useful in this type of exercise. Now let us see how Bayes' formula can be used. Say we were not given all the information, but rather were told the following. The probability of yellow is 9/16, and the probability of red is 5/16. And the probability of red given yellow is 2/9. Could we then work out the probability of yellow given red, the other way round? And the answer is yes. We could construct a table like this one here, and I will show you how to do this in a later video. Or we could use Bayes' formula. We will replace A with yellow and B with red, giving us the probability of y given r equals the probability of red given yellow times the probability of yellow all over the probability of red. That equals 2/9 times 9/16 all over 5/16, which equals 2/16 divided by 5/16, which equals 2/5. This has been an introduction to Bayes' theorem. See in the description below for links to other videos about Bayes' theorem, screening and probability. Please like this video, subscribe, but most of all join the channel, especially if you're using our videos in your teaching. Help the channel grow and help me help more and more people like you. Joining the channel also gives you access to more helpful videos like these. I am truly grateful for my channel members who help make these videos possible. And special thanks to my super supporter Rana Al-Zamil. Thank you.